you see, they're not really, because it was difficult to aliquot, they're not exactly the same size, but close enough. So
and we will do the same with the other one.
With the 20, yeah. Do they look the same? They look quite different. Like what to think. This look pretty much the same. And then everything else, we just do everything.
There was one that was just a pellet of this one.
You think this pellet we can handle?
That's more than 20.
Or is it too much?
That's maybe to divide.
So because this we did an aliquot, it's just...
we did an aliquot. We can maybe split that one too. What we'll do is we'll add 40 microliters of license buffer and just make it 2 reactions.
Yeah, and this one...
That one should be fine.
Just fine.
Yeah, that one should be fine.
So I think in the end we decided to take, because the pellets were quite big, and percent, so we thought
Those I think will be okay.
but like as in to split one of these, right?
That one might even be okay.
Read on its own?
Yeah.
Oh, like for one reaction, you think? Or like 2 reactions from this?
I think we can do 1 reaction from that. Which one is that?
So these are the 10 and 20, because originally we said we should take the 5 and 10, but we only have 1 left, because we used 1 for input determination, so this is the 5.
You could do that one for sure.
Or we thought we could just like split this one in 2.
Yeah, we could probably split that one into 2. It might even be enough for 1. Let's see
I mean, we can leave this as well, we can also combine them. And then this is a 20%, and we have... yeah.
We do that one.
So these 2, 1 reaction each, yeah?
And there was this other one that we were worried about.
This one that we should probably split into.
That one I probably split,
yeah. And this one we can just go ahead.
Go ahead, break for yeah. We can go forward.
Oh,
Look at that.
this is the slime, so it's still pelleted a lot.
That one we might want to do too as well. That's okay. We have it. Yeah, because I think there's still some liquid in there. So I think we'll split that one into 2.
I mean, this has like 150 mBg now, so maybe
It's pretty small.
But I have no idea how much DNA is in there, because like I thought we would get rid of more slime. There's not many cells in here.
Well, we'll split it into 2 and then we'll combine it. It's probably going to be low, but that's fine.
Yeah.
So what we'll do is we'll do 1, 2, 7, 8. This is the bite stuff. So we'll have 12 reactions.
Yeah, we can put this one back here. So
Yeah, so we'll have 12 reactions, which isn't bad.
But it's important. Do your best with the challenging ones.
yes,
I think it gives us a better chance to get you.
No, but of course, because your sample is actually sharp samples where data are extremely needed. Herring, that's for students to see the grinding has worked. So for the herring, we'll take only 1 sample and run it full scale, deep sequencing, the rest of the skimming. And your samples, all of them, they'll be run sharp.
Given we have, if we start with the 800 nanograms and 2 reactions, then we should have plenty of approximately migrated DNA, and then plenty where we, because once you share size, like we'll need about 40 to 50%.
No.
Just from the shares when you do that. So we have 800, now you have 400, you can actually have enough to get 2 libraries, hopefully. There's only 8, so.
And so it's gonna be, some samples are gonna be 1A, and then the samples with a bigger pellet are gonna be 1B. Okay.
So we can take these off of
The dry ice. I can have them in the ice, or I can have them.
regular
Yeah.
ice, yeah. Yep, exactly.
So I'll start with the easy ones. Do we just put them like
That one might be.
instead of ice? I think this is gonna be good for 1 reaction.
I think so.
This one is gonna be split. And this one is very good for 1.
These, I think this is good for 1.
So this for 1.
And then these are probably.
I mean, these are 2 of the same, right? So
Yeah.
we either, should we just split this one, or should we use this?
I think this might actually be okay.
Yeah. let's see. We can
Actually,
do this
I would actually probably split that one out.
The bigger one?
Because remember, there was all that debris when we did it. So
Yeah, so then we don't use this one, but because they're the same, right? So like we just do 2 of this one. Split.
because we quanted 5% for that one, right?
Of this we did 5%, yeah.
So
for
yeah,
the-
so they were double in it. Okay.
Okay, good. Trying with regular tips first to see if I can use this fan.
I think most of them may be okay, just the last couple you won't. I mean, the white work too.
If it's crucial to mix them properly, maybe I would go ahead with
It
a...
doesn't necessarily have to be suspended really well. Just make sure that everything is liquid is covered.
Submerged, yeah. Okay, then I won't do too much so I don't have foam. So this one is with
You can take that
10%.
concentration
The one that we said
we
we
have
don't need to split.
and multiply it by
I
450.
think that's okay.
So it's basically 10 times 500, which means that
Alright, the
it's
other
5
one as well.
micrograms, right?
Might be a bit on the upper limit.
Yes.
In the illusion.
What do you think?
So
This one
you
maybe a
have
bit on the upper
500.
limit.
So you have 10 times more.
Which one is that?
Actually.
This is the second aliquot
So you
that
have,
I showed you before. So like now we have set up 2. So like worst case we
1,940
That's okay.
nanograms and
I'm
would
just gonna
be
take- yeah, that should be okay.
180,
this was a slightly bigger pellet than the first one.
1.9.
The limits one or the pellets with the lysis or
No,
like
how
covered
many?
with the
100?
lysis?
Yeah, if you can cover it with the lysis, then you'll be okay. And the big thing too is, you know, you have big pellets, it's gonna be hard to, so you wanna remove that. What we'll do is we'll add air conditioning to that, and we'll move it to us. You wanna be able to pipette all of that on. And not leave too much behind.
This one I didn't really try to mix because I don't see it, so I don't want to lose any of it. And then this ones we need to do double. So I'm just adding
I didn't do them.
and split it later, so I think I'm gonna need to
So 9.7 times 40.
then we can keep it all in one.
Okay.
That's what I
Just
said.
add 40 microliters of your lysis. the ones you
Exactly, and then we
I
split
was
it up.
multiplying.
And then what we'll do is we'll add double of our conditioning to it, and then we'll just take half of it.
Yeah.
And it doesn't really matter if it's not exactly half and half, just because we're gonna combine it.
It's just the volume. Yeah.
Yeah,
You
no.
don't need to do that because it
No,
needs
okay.
several tubes, right? Several pressures.
You're doing 2 separate
Because I
reactions,
thought
but
I
you can
was
combine it anyway.
I just made
It's not like
one.
you're gonna do 2 reactions.
Yeah.
Do you get it?
This is 1,300 nanograms, no?
Yeah.
We started at 500, right? We took out 15 microliters.
It's gonna be fun to pipette
We,
later.
the leftovers
Is that the one that's,
450.
This is
We
the
reconstituted
bryozoan.
these beads again, that pellet again, with 450. So if we do that, the concentration is the same.
We'll have a little bit more volume because
If we
you'll
multiply that by 450, we end up there.
And you
The top
fine,
of the state specification
but we will.
So these are the normal. So this you just follow the protocol. 24 microliters.
So I don't have to keep them moist, right? No?
Unless you're in a rush.
I don't think so.
Now we can 62 degrees afterwards.
And now it's this up 24 microliters.
And then we transfer it to these ones, right?
Yeah, then we can mix with the conditioning that I'm trusting.
And then these three here, these are double the amount. So we add 48 microliters of conditioning, and then we split it over 2 tubes here. It doesn't have to be like an exact division, it's just like for the size of the reaction they need to be split in 2. He suggests to, when you add the conditioning solution, to immediately transfer rather than adding the conditioning to everything and then transfer.
Add, transfer.
Yeah.
Add, mix, transfer. Because sometimes you'll get, your DNA starts to get released and then it gets really like gooey. And then if you wait a little bit too long, then it gets really hard to pull all that out of there. So I always just mix it really good and then transfer it right away. And do one sample at a time.
This is a good kind. Because now this,
Oh yeah.
that's like DT.
I mean, you guys work with DNA a lot. You know how it kind of turns into like snot, sort of like mucus. The conditioning solution will do that, unless, especially if you let it sit too long.
Yeah.
And you're like, oh my goodness, I can't get it out.
Yeah, there was that one. Yeah.
Do you
Yeah,
guys,
but they
do
took
you guys
the-
use thermocycles or use the
doctor
group took it.
Okay.
I would suggest using a thermocycle. It's got the
No, not here yet. First here.
The heat is way better. I know there's not a lot of
Yeah, maybe they wanted to use.
way better regulation.
Because if it's a cooling one, then they can do this next two steps.
So what I'll do is I'll do license bubbles.
Yeah, but if
Add my conditioning solution, and then I'll mix it really well, get everything off the walls, and I'll transfer it to a. And I think the temperature regulation and using the thin wall strip tube PCR plates. Yeah. If you have thermocycles, we use thermocycles. So.
Thank you.
And then these steps you don't have to be like real careful. You can like put it down really hard. It doesn't really matter. You might get a little bit of bubbles, but
Where is the
it'll go away.
bubbles that I think?
So I always like go up and down the wall just to make sure anything gets stuck there, and then I take it off.
Is it slimy?
Yeah, it's really gooey. And
Yeah,
but
it
when
could
I needed
have,
a little bit more liquid with it, but
Could have a lot of DNA potential.
I think I got most of it. I mean, all of it. Actually. Okay, this also gets really stuck in the walls, and when you put it back, it starts bubbling.
And just suck the bubbles right out, it's fine.
In Norway, if you have property, you usually have debt on it, so your
I'm gonna do a pretty high, 62 degrees. Most of those bubbles will go away after this incubation anyways.
And then it's so difficult to get them up with the
And in Switzerland, taxes are lower.
bubbles like
Use the,
that.
Healthcare.
More liquid.
I would use the other pipettes maybe.
Necessarily then overall.
But what you're getting out of there is fine.
Yeah.
I think so.
I mean, if you need
Those are not low inputs, so you're fine.
I'm trying to mix it before I transfer it.
Is this the algae? The slime.
Yeah, you guys like everything because it remain, yeah. Yeah, this is
We transfer this.
Transfer,
Ugh, it smells. I mean, it's called like that for a reason.
Some mint species, it's actually pretty nice when you're pipetting because it smells like mint.
Nice.
It's nice.
Well, this is called.
Usually it smells terrible, and I'm like, oh, this one smells pretty good.
This is called Hydrurus fetidus. It's for a reason.
Yeah.
So 62 for 15 minutes.
Yeah, 15, not 10.
10?
Want to do 10? Yeah, they've been in there for long enough. Yeah, 10 minutes is fine.
That's what you guys say.
Well, for tough samples, I
Condition and solution with
15.
15 was
Ah,
what
okay,
we
we
talked
can,
about,
I
that
can,
15.
Yeah,
Or
I mean, you can put now here, we take 5 minutes and then wait. Or I put direct in 15
let's do it
here
manually,
and yeah. Without changing and everything. And then we just keep
It's already at the
it.
right temperature.
For difficult
Yeah.
samples, I go 15 minutes of conditioning.
Okay, you're going with
Yeah.
the timer?
We're doing that extra 10% because otherwise we are running out of
13 reactions.
chemistry on the last sample. Because it's quite viscous solutions.
You got it.
So it's
Just kind of pipe it up and down a little bit. You're good. There, that's good. You just want to mix the solution. That's it. All this is doing is quenching the previous step.
And now they go into where?
37.
Yes.
But sometimes you can actually do this overnight if you wanted to. So like if you go longer than an hour and stuff, for sure you can. Or at least an hour. But like for flexibility, it's it's not gonna hurt you, it's not really gonna help that much if you go overnight versus the 1 hour. But for flexibility, because I don't have time to do the rest of this, because you can let this go overnight.
Okay. Yeah, because usually people we're doing 4 hours, sometimes 3 hours, and then continue all of these, and just in the cross-link and overtime.
We've tested 1 hour versus 4 hours, 8 hours overnight. Some sample overnight works, helps a little bit, but it's not that big of a difference.
Okay.
So it can help a little bit, but it's not gonna help you drastically.
So these are the restriction enzymes? Okay. And so you have the DNA cross-linked together, and then you cut it up into smaller fragments for sequencing?
Exactly. You cut up in smaller fragments, and then you ligate it, divide it through half.
Right.
And then kind of group it back together.
Okay.
The next one is green.
And then you sequence it.
Cool.
Yes.
I leave that on ice. I leave your master mix on ice till you're ready.
Yes. Does it need to be pipette mixed or can it be tap mixed?
It's on the forward.
Like just tapping
You
the...
can just tap it.
There is here with the Jess, and then now we should add the biotin, and then we relegate.
Gotcha.
I'll set it at 20 degrees. It just makes more.
I might have seen pipette mixing was not that easy.
And then
Could have maybe just tap the next time.
arrive, and they will start
Room temperature for 45 minutes. And we're using 20 degrees for room temperature.
Yeah, I was stepping it. It's pretty nice,
Like that's
right?
good.
Yeah, there wasn't that much.
For the precipitation, that is. And then I'm just gonna tap it because I otherwise need to mix it with whiteboard because
So Tuuli is the one who's working and you're just hanging around there.
Her support team.
Emotional support.
Yeah.
come off the bottom.
It's okay.
You think so?
It's such a luxury to
It's
do
gonna
something.
settle so fast anyway.
Just so that the enzyme gets to everything.
You just have to steal his password to lock him.
Resume. 15 minutes.
Sorry to be a bit late. We have tissue.
Up on the top, there you go.
Because
You couldn't find
Can you
that.
pass me some tissue? We have beautiful here.
Yeah, they're a little bit full, but
That's
okay.
It's not that amount of cross-contamination that I'm worrying about.
You can skip this 25 degrees and go right to 40 degrees.
Yeah, because that's just
That's
equivalent to for the beat.
Exactly. So you just go to 4 degrees, and then tomorrow when you get done, you'll take it out.
And 16 hours. So
16 hours, yeah. This is a
How full does
you're
it
doing
get?
on the same day for 90
Pretty
minutes.
full.
All that debris in there really doesn't mean anything. It just gets in the way, honestly. So. What I'm hoping for is during this step, that some of that, hopefully most of that will go away. It does smell a little bit. It's the sulfur. Yeah. No, there's no beta-methyl ethanol or anything in there. Yeah.
Okay, perfect. So we're good to go.
I'll give you guys advice on just something I noticed. You guys are very, very meticulous. All of you are very, very meticulous pipetting. You don't have to be that meticulous. Seriously, it's not that sensitive in the assay. Like when you're mixing, you don't have to be like really slow. And, you know, you guys are doing your tip touches to try and get every little drop off. It's not that sensitive. You don't have to do that. You can go a little bit faster and move a little bit quicker, and you don't have to be that. It's not going to make a difference. It's not a bad thing to be that. But sometimes speed is the essence too, because you need results. So you guys can go a little bit faster and be a little bit more aggressive with your pipetting.
Do you think it's important to use the whiteboard tips, or we can use like
I would say it's your preference. Like for the mixing, it's not necessary that you're mixing up all that debris. Like I said, that debris is just garbage in there for the most part. So it's just making sure that your solution is homogeneous. Like when you're adding your enzymes, make sure that you get a good mixture that, it's not all sitting at the top. It's eventually going to get mixed in there, but you want to mix it a little bit quicker.
Yeah, because that was why I changed the whiteboard, is because the tip got clogged.
Clogged, yeah.
Most of the time, the tip gets clogged.
And what you can do instead of,
afterwards.
Yeah, exactly. You can just tap your tubes and make sure it's a good mixture.
And especially when there's on a strip, it's so easy, much easier and faster than pipetting each.
Especially so like we had multi-channels.
And use multi-channel pipettes as much as you can. It makes things a lot easier. I mean, obviously when you're making your master mixes, there's not enough to pour into a bowl. So you got to go single, but like tomorrow, everything should be able to multi-channel be so much easier.
So tomorrow, do you get to know finally if it's turned out, or do you have to wait?
Well, we do qubits.
Yeah, and then we have the QC1, which already tells something, but
how much it will go with the beads, so we know some about the length as well, right? No, only yield.
Only yield.
Yeah. The other one is
at this point, if you run a tape station, you're going to just get bands all over the place because we haven't shown anything. We like getting the DNA together.
Tomorrow we find out that it could have failed or still be good to go, but not if it has worked.
I'm guessing, worried about the, like I say, insect samples. Because it was just one bug that's I mean, we might get something, but is it going to be enough to move forward? I don't know. We probably won't. My guess, we probably won't have enough to do QC1.
Because that was 275 nanograms. This was 75 nanograms for the QC.
Yeah.
And
but if we have 50 to 75 nanograms total, I would still move forward with library. But I just didn't think it's going to be QC1.
We can also find out if that was it. Like with I think this is it. It's just that we did not have the option to work in a pool, and then I guess we just have to try.
And the good thing is if our other QC1s that we do have enough pass, then we'll assume that we have isolated product. This is email from you guys.
Do you have a precipitate?
A little bit, yeah.
A little bit?
Okay, let's see. It's not too bad.
No.
A little bit in here. See how it's a little bit white?
Yep.
I'm just holding in between my fingers just a little bit. Is there any precipitate? Five minutes.
I had it really right to the top, but yeah. Sorry.
Just want to let it get clear. Or is the other side? Can you see?
keeping them separate. Good to see both of them.
What happened? We're losing in smaller volume.
Okay.
These two samples have like a little bit of debris in them. See them? Hopefully it doesn't get pulled out. I just want to try to magnetize it.
I think I saw one had something in it. Was it?
I'm gonna see if
Yeah, see if it's.
I want to see if it's beads or if it's.
What is it?
The group was calculating it for Alex's chapter 1 training this week. Zinkenberg.
It doesn't.
I introduced Carola
Maybe it has oxidized and it's.
Yeah, see, it's not really magnetized.
Because it was very green
They actually
yesterday, but they
specialized in
assume.
very difficult examples. So I thought it would be good for you to talk. She actually invited her over, but her family is complaining and she's done so much that so that she can't go. Their son's birthday speaks. Yeah, but apparently the Alexa, apparently they're pipetting it in units. The museum in Frankfurt.
Yeah, but the life is pretty strong.
Yeah, so they back to see her again. I saw it. Had fun.
DNA extraction.
So is it for all the samples you're getting? Because I mean the usual life.
I mean that doesn't even really
have a look
left when it's fresh, so I assume it's just.
wonky samples.
That's the way it is.
It's right.
All right.
You want the challenger samples?
I can see how it's brown. There's debris in there.
Oh, it's a lot.
Yeah. So. I tried to centrifuge it down and it doesn't pellet, so it's just try and spin it again.
Are you worried about that interfering with anything? No? That's cool.
It is what it is. You can't change it.
Yeah.
And I don't necessarily think it's the debris. I just think that the DNA kind of got stained that color, and that it's brown. Because I tried to spin it down, and nothing pelleted it. So it's just the color of the.
Sometimes DNA is colored and it has all sorts of stuff in it, and then otherwise you have to do several purification steps of
But you
different
lose a
in
lot
order to. Pardon?
if you do a lot of purification.
Then we
you
lose a lot of DNA as well.
So I don't think it's necessarily debris. I just think it's stained.
When we have worked with DNA extracts, but actually at the library was removed. So it's just like pigment.
I had a big one. Yes.
You can never get rid of. Still sequences.
There were so many of
Yeah.
So this is approximately like you did DNA now. Just have to clone it.
Yeah.
And crystals and prayers, right?
We start with 2 microliters. I mean, some might be quite concentrated. Some might be quite high sensitivity, but this is the high sensitivity. But should we start with 2 microliters per sample?
I don't know, a lot of these are low input, so I'm not expecting it to be out of range, but we'll see. Maybe Giada might be. But we did split them, so.
Yeah, and actually this looked like a lot in the beginning, but it really held it strong.
Fingers crossed.
Yeah.
This is the slide.
This is the one that's got all that debris. Yeah, this one's I'm worried about. Still got something. 800, that's not bad.
That's not
890.
bad.
Yeah. Which one?
Bit more.
Number 2?
No, sorry. I didn't. It didn't make sense.
I was like, wow.
It's a beautiful touch screen of the qubit. And now we have the mosquitoes.
Let's see mosquito.
The low expectations.
It measures it.
That's almost 200 nanograms, so that's good because you can go right in the
Yeah.
library prep with that. Yeah, for sure.
I think this one is slightly bigger mosquito. No. Yeah.
This one was the one that we grinded
That's
before.
the volume
Yeah.
you're taking over your sample, right? But that volume needs to be in a total volume of 50. So then you take 50 minus that sample volume and
So we
So we will have to dilute
the dilution factor.
Yeah, the yield has never been an issue with this
The
one.
total reaction volume or sample volume of 75 nanograms and 50 microliters total.
And this was the worm, so not too bad.
Oh, that's not bad at all.
What was the worm? 1.9.
So 200 nanograms.
And the second life can.
You guys did good.
Similar to the other one.
It's the same. No,
Nice.
Okay, so then we just need to dilute this one.
Yeah.
10.
You could, what I normally do is I usually will take 20 microliters out
20
of that,
of these,
and then it's like a 1 to 10 dilution.
Yeah.
Okay.
You guys did really good for some of these goofy samples.
Let's see the QC1.
I wouldn't do QC1 with all of them. So like this, if it's below 275 total, like this one, I wouldn't do it on height. Save it, I'll just go to library prep.
Yeah.
This one, that's the only two. Just those two.
Yeah.
I wouldn't. No, these three. This one, this one, and this one.
Yeah, the one.
Because this you got 200, 200, and then 43. So I would just. Yeah, you're gonna take everything forward in the library prep anyway.
Yeah.
So if it fails, you're gonna have to repeat it regardless. Or redo it, whatever. If it fails library prep.
But then there's also
With these
shearing.
numbers, I mean, very rarely do we get library prep failure. Now, is it good complex libraries? That's a different
Yeah,
story,
yeah.
but you're gonna make something.
Yeah, but it's a library.
But it's good news that we made LPs. It's a good sign.
But yeah, we got from everything, because the ones that didn't show,
The one
that was
was-
too high,
the one-
right?
Yeah,
Or was it too low?
the one was only 43 nanograms, which is low. But you can still make a library out of that. I don't know how complex it'd be, but
A library.
you'll make a library.
So we're just having our maths wrong, so we got it, but because I set the qubit to 20, but then you have to do it like times powers. Like so I just set it back to 2, so that's 5.49.
So it's 5.49, so it's 54.9?
Must be, right?
Yeah, it's 50, so it's 54.9. So you have almost 5.5 micrograms.
We're still not
I'll see when the bridge is ready.
Thank you. Thank you, okay.